All right, we'll go ahead and get started. Welcome to 2025. Happy New Year, everybody. This will be our first one of the year here. We've got a lot of them coming throughout the year. Appreciate you guys joining today. What we've got today for you is the HVAC Ductwork Field Inspection. I know we've gone through bits and pieces of this in the past. I thought I'd put some of this together and get 2025 started off right by adding some HVAC to that, helping you guys in the field look at things that are whether or not it's correct or not, and actually the implications of what happens when it's not correctly installed. So, thanks for joining us. As always, today's webinar is being recorded. It will be uploaded to our YouTube channel, which you can find by either searching Spear on YouTube or you can go directly to our website at eepartnership.org. Under our news section, you'll find our resources page. Once you're on our resources page, you'll find the link to our channel. We have well over 150 videos that are up there and been uploaded on a variety of topics that can help you out with training and field. Unfortunately, we don't do CEUs for pre-record or for recorded webinars on YouTube. You have to be live for that. So today's webinar is eligible for ICC CEUs. You must be present for at least 3/4 of the presentation. Within about 72 hours, you'll receive a course evaluation email from Kathy Lawrence. Please complete that survey and send it back to her and receive your course completion certificate, which will contain the course ID and title, so you can use that to report your CEUs when reporting to ICC. Lastly, as always, we'll have the chat feature open. I will also have the Q&A section that's going to be open. I'll be monitoring those as we go through it. If it pertains to the question or the slide that we have up at that time, I'll go ahead and run through it. Otherwise, we'll wait till the end and go through it as well. So let's see. All right. So Kathy usually get those things out pretty early. So I always say 72 hours just allow for holidays and things like that. But she's pretty good about getting onto that right off the bat. So we'll get started with this today. If you're new to Spear, for anybody that's new here on the our YouTube, we provide trainings, webinar, in-person, field training. We're a nonprofit. We're one of 6 RIOs throughout the country. It stands for Regional Energy Efficiency Organization. We are member based. We've been 65 plus members with a wide variety of efficiency industries, from product manufacturers to cities, local municipalities, third parties, both commercial and residential. So we appreciate the members that help us kind of advocate for the movement of the energy code. We're focused on outreach, education, and collaboration for clean energy. We assist cities with the adoption of energy codes. I know the 2024 is out. We've got some cities that'll be skipping the 21 and navigating directly to the 24. We can help review some of those things and talk about amendments that other local cities are going through and adding to their 2024 adoption. At this point, no one's on the 2024, but there are several cities in Texas that are looking at that currently. So we can help navigate. So speak to the importance of why. Why did I want to talk about this? So there's been field pictures that's come to me by a variety of sources, and a lot of the stuff that I've used from when I was previously an energy inspector. I took some of these pictures and created this presentation we have today. But you know, putting in a ductwork, it's kind of like, it's a straw. It's got air moving through it. How bad can it be? I'll just start off by saying I'm not a certified HVAC installer. I worked for one for over 10 years, but I was in the energy department. So we had to deal with HVAC from our company itself. I probably red tagged the majority of their work. So our guys were as hard on our company as other companies that were out there. But it's important, and it's no different than an electrician or a plumber having to install their work correctly. But I can hear some of the responses out there, and they're saying, well, that's not really health and safety. I mean, plumbing and electrical, that's health and safety. Energy, they don't really see that blurred line of where it can be a health and safety. But I personally think that sick, humid, dirty, and unhealthy air that we breathe in our house is and can be a predominant health and safety issue. It can also cause major damage to structure over time due to high and low humidity issues by having a system that has poor ductwork installed. It can be modeled, and the best efficiency equipment can be installed, but once you start tying those arteries to that system and it's not installed with care and correct and proper installation practices, it can ruin exactly the efficiency of that equipment that you've purchased. So now let's go through some everyday normal installations that we see. A lot of these pictures I took myself, others or I found off of Google, but it paints the picture of what we're looking for. Just keep in mind the very first thing we're going to go through is from the 6th edition of the ADC, which is the Air Duct Council. It's a manufacturers group of a lot of flexible air duct manufacturers that put this together to say, well, we need to talk about best practices and what's the proper installation. And since we've got this ductwork and there's airflow moving through it, how do we make sure that what's produced at the plenum is getting to inside the house and also what's returning back to the system? We'll see a lot of this a little bit later. So these councils gone through this. It's published in 2021. If you go to their website, which you can see here at flexibleduct.org, it is a. I found it on Google. I don't know if it was the right link. I didn't put that link on here, but if you go to their website, it is a book that you have to purchase. It's a digital copy, but you can go through it page by page and look at that. But we'll talk about some of it specifically in just a second. The good thing at the end of that book, or part of that book in the chapter, it's what are the practices to avoid that they list. And we'll go through some of those, is duct contact. So when ducts make contact, their temperature dip between the ducts can easily drop below the dew point of the temperature. It can start condensating inside and outside of that duct or on the outer layer of that duct. So insulation compression, so compressing the thickness of the duct insulation significantly impacts the duct thermal performance, resulting in, again, surface condensation. And then insulation contact. Avoid laying duct on an attic insulation in areas that are conducive to condensation, especially in humid parts of Texas. If you lay that on the attic, then it's going to sweat between the attic insulation and the duct itself. So they should be properly suspended to allow free circulation around all surfaces of the duct. And then, of course, avoid adding any external insulation. It seems counterintuitive when you say, well, I'm just going to put another blanket of insulation over this because more is better. But you've already got a layer of vapor barrier, which is that silver mylar on the outside. That's where if you've got now insulation laying over the top of it, there will be condensation in between that on that vapor barrier, and it's going to cause an issue. So over tightening of strapping, so avoid installing ducts that are supported with too tight of a strap. We'll see those pictures in a little bit of what that looks like. Exposed metal fittings. I can't tell you how often I see this, is you've got exposed metal fittings. They've put a zip on the outer jacket of the insulation, but they didn't quite pull it all the way down. There are a lot of HVAC guys that have started the practice of masticing the insulation to the plenum or to the collar. I don't particularly care for that. I know why they're doing that, but it also hides points of leakage. And if there is a duct failing, the duct test, they're going to have to rip those apart to actually find it. Improper sealed inner liners, so avoid air leakage. That's just, we're going to do a duct test now. And so we're going to verify that it's actually got leakage happening in there. But when that air comes out, it can come out of that inner liner. And even though the jacket of the insulation is sealed with mastic or a zip tie, that air is going to feed back through that insulation. It will show up as duct leakage. It will cause condensation issues within the duct itself within that mylar. And of course, torn or unsealed vapor barriers. It's probably, I would have to guess, probably 60% of what I saw, there was at least one duct that had a torn mylar vapor barrier on the outside. That can result in condensation forming on the exterior and interior of that liner as well. So if you look at this picture, I'll explain what those pictures are a little bit later. That one on the left is kind of destruction. But why is that important? I mean, it's easy to say, higher utility bills because you're not getting the airflow that you need to the room itself. You're not getting the temperature of air to the room because it's being heated up as it travels through the ductwork due to multiple issues that we'll see later in the presentation. Weak airflow, excessive noise, poor insulation, frequent breakdowns of the system due to the fact that it's either starving for air or it just can't force enough air through smaller ducts or ducts that are compromised with crushing ductwork. strapping material that's causing compromise, visible damage to the ducts, poor air quality, and uneven temperatures as well. So that's air imbalances, temperature imbalances within the house. A lot of these things for code, we don't go back and test these. When these show up, it's a homeowner occupant complaint. It's comfort issues that they're calling about. They start with the HVAC. If they can't get that satisfied, they either reach out to someone else that did not work on the house, or they start calling the builder, or then, ultimately they may even start calling the city and saying, look, I just can't find resolution to this. And so that's kind of the stuff that I'm trying to avoid by just giving you a picture of what it looks like when you're in the field. You can see it and go, aha, that something's not correct here and it needs to be fixed. But as always, again, why is it important? Condensation inside the ductwork, condensation outside the ductwork, potential organic growth happening in or out of the duct or even on the grills inside the house. This can be caused by multiple things and multiple issues. In a humid bathroom or something that's got a vent and people don't run the bath fans to exhaust that humidity in there, that can happen. But a lot of times it happens because it's just there's cold air hitting hot somewhere. There's either the boots are not sealed or you've got something wrong with the ductwork and it's causing air to stagnate there and condensate on those points. But as you see, the one on the bottom has got the inner liner that has bacteria buildup, mold growth inside the ductwork. It's a lot of it is just dust as well, but it's unhealthy indoor air that can be causing those problems. So as an inspector or an installer, when you're out there and you're looking at it and you're saying, well, and a lot of times when I go speak to cities, it's just give me the 5 top things that I need to look for, the 3 of the top things that I need to look for. But here's 4 of them that this book lists, and it's the 4 S's. We've talked about this in previous presentations, but it's smooth, it's sealed, it's straight as possible, and all ducts are separated, especially in the humid climates. And it's not just from each other, it's also from framing members, roof decks, radiant barrier decking is a big one, service decking, other HVAC equipment, and then, of course, attic insulation, including foam. So smooth, the duct needs to be pulled as tight as possible with very little compression. You're taking the slinky out of it. And then sealed with 181 approved materials, either mastic or a tape that's UL 181 approved. And then straight as possible, very little kinks, sharp bends, or sagging. And we'll look at that a little bit as well. So slinky equals friction loss. I don't know how many times I have to explain this in the field. And again, we're the inspectors, or I was the inspector. I was a third-party energy. I'm looking at the ductwork, especially with Energy Star. This is a big deal. With code, it just says follow manufacturer's instructions. Well, if you do that and you read their books and their guidelines, they talk about all of these things. So ducts should never be pulled too tight where they're causing compression or kinking at the plenum. But they still should be done where there's no compression or slinky happening inside that ductwork. So friction loss is expected. It's accounted for when it's being designed in the system. However, there's estimated that there's 0 to 4% compression results in what they consider correct friction rate. So when you're looking at a friction rate, you're designing your duct system, you're designing your HVAC system, you account for some percentage of friction rate. So when that happens, usually it's a 0 to 4% compression. Compressions of only 15% can double that friction rate or even quadruple that friction rate. When you've got 30%, it quadruples that rate. So when you have friction loss, that equals loss of airflow. Air gets trapped in the ductwork. It starts spiraling around all those ribbed liners inside the ductwork. It can't get to where it goes. It causes turbulence in the ducts. You can measure air at one end and have ducts poorly installed, measure at the other end, and that's what this webinar is about today, and you'll actually see that it was a problem and it caused a reduction of airflow. Where did it go? It's still inside the ductwork. The ducts are not installed properly enough to get that duct out the other end. So, flex duct I'm sure it was created because it's an ease of installation. It's easier than having the tinners out there that do metal duct work, and you've got the seams, and you've got all of that here's no longer duct board. You use flex duct, and it makes it super simple. But there are proper ways to install it, and I think some of these installers that are out there has somehow lost some of that skill that's out there when they look at it. And that's up to now inspectors or building official to look at it and say, is this correct? So we talked about a second ago, this is, ducts not being in contact or separated. This is just an illustration out of that book that just shows 6 ducts coming out of a plenum. They're right against each other. The collars have been installed too close together, causing those ducts to be in contact with each other, especially at the very beginning of that supply plenum. That's the most extreme temperature differences at that point. So if you've got a extremely cold attic and hot air coming through there, you'll see condensation, and vice versa when you've got a very, very hot attic in Texas and you've got very cold air coming out of that plenum. This is where condensation will happen, is at that point right here. Another field verification picture, just looking at this. You see these pictures all the time. I see this in the field all the time. You just see ducts laying on top of each other, especially if they're trying to stretch up from a first floor attic to a second floor attic. They just kind of lay against each other, or lay against the framing member, or lay against the insulation. As you see on the right, it's laying on the service deck. It looks like a supply is probably laying on a plenum, which is really not a good thing. And those ducts just kind of intertwine together. They all should be supported and separated as best they can. Another big one is going up against roof deckings. This happens a lot as well. First of all, you've got nails penetrating the vapor barrier. Hopefully it's not getting all the way into the inner liner, but this thing's strapped pretty tight against that decking. I understand if you drop that strapping and don't lay it against the decking, it's going to have a hard turn into that chase or into that boot. That, in my opinion, is where you should have a 90, a metal 90, a metal 45, something that's not going to cause this thing to lean up against or be pushed against framing material. This is a non-radiant barrier decking, and we realize in Texas that 160 degrees during the hottest summer, and that's going to be right up against it. So trying to push 50 plus air or 60 plus air down this duct tube that's now got at least, I'd say that's probably 4 or 5 or 6 feet of in contact with radiant decking, with nails penetrating into the insulation, is going to cause a problem. It may even sweat and drip out of that vent if that's a boot. If it's a chase, it may not. Of course, we've talked about this many times before, is the cut and stabs. So these pictures, I don't know if they have Ys in them or not. I can't really tell. These are taken in field. It's also taken off Google. The one on the far left with the black tape looks like it has a Y in it. The other two are questionable, especially the one in the middle is questionable. I don't know if that's got it in it. A lot of times when I was in the field, I would take a PVC pipe or just a short stick and just kind of push up on that. If you push up on it, you can feel that there's no weight to it. Those metal Ys have a lot of weight to them. So if you push up on it and you don't feel any resistance, or it's very, very light, that's probably meaning they just cut and stab that together. And it's that mastic like that, or the ball of tape like that, is a telltale sign that something's probably not been installed correctly. Same with this, just more examples of that. Again, it's unknown whether or not there actually is. The one on the far right looks very, very suspect. The one on the left looked like, I think that was the picture I had a second ago, but it's bigger. It looks like there is a proper Y that's been installed. So proper clearance from the plenum and supply plenums, the supply plenums and the return plenums. We saw that a second ago in the illustration. This just is kind of a field picture that we picked up. That we see this all the time too. It's ducts that have, and again, if you read the book, best practices says allow anywhere from a 12 to 18-inch clearance for the takeoffs from the end of the plenum. In this photo, I know I've had it in previous presentations, there was plenty of room to build this plenum a little bit bigger and have those things not right up on the end. If you're kind of unaware what really happens with air and how that moves through, I mean, if you get supply air shoots out of the top of the air handler or the furnace, it slams into the back of that plenum first. It doesn't just take hard rights and go down ductworks. That's not how air moves. It actually gets to where once it hits resistance, it's going to be pushed in different directions. So in this case, these ducts that are right there on the end of that plenum are going to get the highest pressures, meaning they'll have the highest CF film push down those ducts, and the ones further upstream closer to the air handler is going to be probably having reduced airflow as well. So not planning this correctly, not having the plenums set up to where you have the collar and the takeoffs with enough clearance, you just lead to, it's all based on static pressure, and now you've got supply issues, you've got airflow issues that now have to be fixed or verified. A lot of times we look at it and think, well, if they put supply dampers and all of those, they could balance that air, and that's true, but that normally doesn't happen from contractors. They just install the duct straight off the plenum without dampers in them. This is another one I've used before in previous, but if we're just looking at this, there's a lot of, as I listed, there's a lot of nope, that shouldn't have happened going on in this picture. So we'll just list them really quick. It's supply ducts off the end of the plenum. We've already talked about kind of that. If you put it on the very end, that's even worse because that's where most of that pressure is going to go. And then ducts in contact with each other. Takeoffs installed without proper clearance at the end of the plenum. As you see around it, they're really close to that end. Sagging return duct in that far picture in the very back of that photo. Ducts in contact with framing materials, service decking, attic floor insulation. Ducts being pulled too tight, causing collapse against that collar at the plenum as soon as it exits that supply plenum. This is a lot of times when you have HVAC being tested for static pressure from Energy Star certificate or certifications. You're going to have to take that static pressure reading of the supply plenum and the return. This is where you'll have really high static pressures, and it's due to ducts that are being compromised right at that plenum, being compressed or collapsed against those collars. And then, of course, there are a little bit of the strapping being pulled too tight, causing compression of the outer liner as well. So there's a lot going on in this photo. So the ADC still recommends that you need to just be supporting those things coming straight out of the plenum. It needs to be supported at least. The rule of thumb is always within the distance of the diameter of the duct. So if it's an 8-inch duct, that first strap needs to be at least within 8 inches of that collar coming off the plenum, and you support that correctly before making its first turn, either with or without fittings. You need to support that. Those two pictures on the right are exactly what happens when you don't do that. As you see, they are strapped, but they've been pulled so tight that they're collapsing against that collar, and that's going to cause a back pressure issue into the supply plenum, causing higher static pressures than are needed for that. Short runs, this is kind of hard to overcome. You've got, the plenum is there, you've got a boot or a return that's just below it. It's kind of hard to get that flex duct to not end up collapsing over itself. If you see that picture on the right, they did as best they could to not cause it to collapse at the plenum. That's great. But if they would have put two straps on there, they could have smoothed out that bend a little bit and not cause some airflow issues. This could technically also cause noise issues because it's so short and it's got that kink in the ductwork. There could be a noise complaint from where it enters into the house at that supply plenum, or at the supply right up into that room. Again, another picture of excessive sharp bends. Looking at that, the picture on the right, you'll see this quite a bit happening, especially with returns or a single large trunk supply coming off the top of the air handler, and it has to bend back to a distribution box. A lot of times this is not supported correctly. As I said a second ago, even in bends like this, you're supposed to also have that sweeping bend at no less than the diameter of the duct. So as we see today with the increased insulation of ductwork, if you have an 8-inch duct, it's probably more of a 12-inch diameter because you have almost 2 inches of insulation on the outside. So you're only looking at the inner lining of the duct, making sure the diameter is going to be that or greater so you don't have a crushed elbow, which looks like this. This is pictures I took in the field. This is exactly what we're talking about. I think the one on the right is the one we saw earlier, but it's looking at it from the top. So looking at it from the attic itself, you can clearly start seeing that there are strapping issues that are here. It's crushing the outer insulation. It's also going to be causing airflow issues with that. I know it's time is money and you've got to install it as quickly as you can, but doing something like this, you're just hurting that airflow to reach the room that it's supposed to be in. Another field verification photo looking at this as well. Same kind of thing. It's not as sharp of a bend as we just saw, but it still is going to have compromising of airflow. So that too needs to be corrected. The one on the right, it's in a foamed attic. They did a great job of not having it in contact with the foam, which is great. But still, with airflow and trying to move air through certain size ducts, you need to support those things where they don't have this issue, which kind of looks like this. These are some photos that I picked up off of Google. If you look at that, the one on the right hand side is in foam. It's not in contact with it. I don't like the fact that rafters are exposed, but it's neither here nor there. But there's saddles on all of these. They've strapped it multiple times in the bend. It's a sweeping turn. It's not a collapsing or cavitating and just falling over on itself and crushing that airflow. And the one on the left is actually running through floor systems, and they did a great job of just kind of sweeping that around and not having that just come out of that TJI and then immediately just get folded over, which happens a lot. We'll see more of what that looks like in just a second. Same thing with bends happening. I just showed that picture a second ago, but this is kind of, even if this shows this being horizontal, but if you picture it doing it the other way and doing it vertically, it's just having strapping on both sides of that bend gives you a much greater radius to have proper airflow instead of compromising the airflow by having that bend over like that. A lot of this with this webinar that I'm going through is just for our inspectors that are out there, that it is incorrect. It is causing an issue. It will cause problems, and we'll see an example of that towards the end when we actually see measured airflow on new construction. Sagging of ductwork, same kind of thing. The more it sags, the more friction loss we have. I took this picture on the right hand side. This is exactly what this one looked like, was just sagging in the middle. And of course it's crushing the outer insulation a little bit, but that sagging shouldn't happen. The sag rule of thumb is basically a 1/2 inch per foot. And of course you're going to strap it every 4 feet per the code. And if you do that, then you can't really exceed a 2-inch sag in that middle. That picture that I took is greatly exceeding that 2 inches of sag in the middle and should have an additional strap there. Another field verification. This is just showing excessive strapping. It's over tightened. They're using the noose style instead of just kind of looping it on some of them. Some of them are actually looped. If you look in the very far background, they did a great job of wrapping it a couple of times, kind of creating a saddle out of it. But then all these smaller ducts right here that we're looking at that's in front of us, they just did a noose style and just crushed it. I don't know if that was two different people. I don't know if they just normally do this with smaller duct diameters, but it's excessive and should not happen. If this was an Energy Star home, this would be red tag for that issue right there and would have to be corrected for Energy Star. And really, it should be for code because that's following manufacturer's instructions. And as we saw with the ADC, it's going to be also manufacturer guidelines, and that's kind of what this group put together was this is how we consider it to be properly installed. And of course, we saw earlier a little bit of example of this, but laying it on framing members. It does say you can do this, but you want to avoid kinks and crimps and excessive bends with this. I don't think in Texas it's a very good idea using framing members because if you think about it with the picture you see on the right hand side, this attic's 160 degrees in the dead of summer. All of those framing members are at least 140 plus. So if this is now all touching it and leaning against it, this is points of condensation that will happen within that duct, either inside the insulation itself, on the outer jacket itself, or even possibly inside. Thanks, Eric, for noticing that. I'm not sure. It was just noticed that my voice is cutting out. I apologize for that. I don't know. I probably have a poor connection for today. A lot of people are home due to the weather. Hopefully that'll straighten itself out. Sorry for the difficulties with that. And you should never see either one of these during your inspections or out in the field. So I replaced my ductwork last year. I had those triangle boxes. This is not a picture from my house, but they look just like this. I actually cut those things open just to be curious to see what did this look like inside there. That ductwork was very, very old. And of course, a lot of it with the pressure that they exceed in those triangles, it blew itself apart over time. And of course, there were things growing inside of it that I probably shouldn't have looked at. But this causes pressure imbalances and comfort issues throughout the house. So you should not be seeing things like this. And the one on the left, of course, it's a crawl space. It's not as big of an issue, but you should not be just crushing the outer insulation at any point. Unless it's in a conditioned foamed attic, then they really technically don't have to be insulated. that's not really probably going to be a point of contention or problem that goes and shows up, but best practices is just not to do it. There are some cities in Texas, and I commend you guys for requiring saddles to be installed. Most cities don't. I don't know if they don't see the need for them, or they think it's just a new cost to the contractor and the builder. But it can mean a lot when you have people using new style strapping and they're just kind of overly excessively crushing the outer insulation. ACA actually puts together a fitting EL, equivalency length chart, that's like 2 or 3 pages long. This is just a snippet out of that, but you can find out when you're looking at Manual D. For their Manual D, it's in the Manual D chart. But when systems are designed and the lengths are determined, that's just for the run. They say, well, that's a 35-foot run. But the equivalency links also must be assigned to each fitting, and then the turns and the bends, and this results in a much longer run than just a stretch string distance from plenum to boot. And this is an example here. We've talked about it in previous presentations, but you're looking at off the EL chart, 90s are 20 feet of equivalency length. The 45 is 10 feet of equivalency length. The 180-degree offset, which you may not see one that looks like this right up against each other, but eventually it does this within 20 or 30 feet. That gives you an EL of 40 feet. So for this example, if we had a stretch string distance of 10 feet and then you've got 180 offset, you've got 145 and 190, that equivalency length is 80 feet. So from a 10 foot to an 80 feet, that's 70 feet different. And now that's, when you look at it and say, well, that's not really 70 feet, but due to friction loss, due to pressure differences and back pressure in the system, just the hard point of now you've got airflow that's fighting against itself, it's turbulence against the wall, it's spiraling backwards and forwards, and it's just causing problems to, it's the equivalency as if it was running 70 more feet. So just think about it that way. If you're pushing out 100 CFM of air, by the time it gets down to that end of the 10-foot run, but it's gone through all these different fittings and offsets, it's like it had to run another 70 additional feet, which means you will lose airflow before it actually gets to the house. So, it's not a perfect install, but just imagine what we're seeing today with the bends and the kinks and the sharp bends and the crushing and this is the stuff that I took pictures of, and I'm sure you guys can probably attest to the fact that, yeah, this is probably what you see on a daily basis. We've talked about this before, but sealing splices and collars and just a point of airflow leaving because of leakage is just having a proper mastic installed with that. And of course, the right way to do it from ACA standard and from the ADC is you're talking about at least 2 inches on the fittings, and that needs to be the thickness of a nickel. And then you slide the inner liner on, and then you can mastic that inner liner to the collar and then add a zip tie to it, or do that first and then do that. Sealing that outer liner to the fitting is not necessary, in my opinion. It could be a sign of improper sealing and that someone's trying to hide something. I do know that they probably do that because they do have problems of the fittings being exposed because the zip ties are being put on too tight, in my opinion, and it's causing that insulation to flare backwards, and it's exposing those collars. They're having condensation issue at the collars. I understand why they do it, but then you have things like this. On the outside, it looks like it was a lot of mastic. I took these pictures, but looking in from the floor and looking up through the boot, I saw no evidence of mastic either in the boot. So if you go up there, all I did was cut just the zip tie off of it, and you realize that they didn't even mastic the collar. They just put mastic around the inner lining, and then just pulled the insulation down over it. This is a complete wrong way to do it. This was found, again, because it had a failing duct test. So you're looking for solutions. You're looking for why it's failing. And then just so happen you start finding things like this. I didn't go and destroy the entire system and start pulling it all apart. Basically, you have to tell the contractor you're going to have to look at every connection, because apparently this guy was trying to go a little too fast and just skipped putting mastic on the boot where it belongs and not installing it with the proper installation practices. Floor trusses, this is showing up a lot more. It turns into be a problem with, well, where do you run the ductwork without having problems? These pictures were taken just last year. of a house that was being constructed, multiple houses being constructed. So it's not always the HVAC installer's fault. That may be the best installer possible, but he is limited to what he has for him, against him, and in front of him to actually have to run ductwork. But this, in my opinion, is a major problem. And we'll see the results of that in a little bit towards the end. But the engineering plans aren't designed to have ducts run through this. I mean, I understand that your material is money. I get it. But these floor truss systems, in my opinion, are not big enough or deep enough to house mechanical ductwork. It's just, it's a problem. It, as anything, you look at it and say, well, is it installed? Yeah, it's installed. Could it have been better? Absolutely. Is it going to be a problem? Most definitely. But how do you fix it from this point? There's not really a point of fixing this without finding another way to run ductwork, and that's probably limited to the house size as well. So sometimes the installers have little options. With these two photos, it doesn't look too bad. It is between conditioned floors, so kind of crushing the outer insulation isn't as big of a deal. But the bigger the duct and them trying to fit it through those little triangle openings, you're starting to kind of oblong or football shape that duct, trying to get it through there, and it's going to cause airflow problems through that duct. This is kind of what the EPA put together out there. This was off of an Energy Star where they show a thumbs up and a smiley face for perfect and done well and correct. And then they show a frowning face and a thumbs down for what's not being installed correctly. But here, if you look at it, I mean, in my opinion, properly sized trusses, they're actually able to run ductwork through it without having compromising of the ductwork or the outer insulation running through it. If this is over a garage, I would prefer to see that duct being supported on the floor above so it's not in contact with the sheetrock on an unconditioned space. But that's kind of my point of view from it. It really needs to be not in contact with something that's going to not be conditioned. Would I fail it for that? No, I would probably just make a note of this probably could have been better if they supported it against the floor being conditioned. I found this on the internet. It was just interesting to see it, but they consider, if you would consider ductwork being the arteries from the heart, which the heart would be the HVAC system. So think of the ductwork as that, and if ductworks are not properly installed, the heart or HVAC system will fail permanently, prematurely, and altogether. Improper installed flex ductwork is a heart attack waiting to happen. In other words, you will have equipment issues. There will be comfort issues. As you see in the pictures on the top, it's properly installed flex ducts, supported very well. They're running through floor systems, but they're still done, in my opinion, correctly. On the bottom right, it's just a web of mess. It's an octopus of just ductwork all running against each other, touching framing members, overstrapping of the straps, sagging going on with that middle picture. And of course, the plenum on the far right picture, they're just, in my opinion, too close to the end of those plenums as well. So the system will not last as long. There will be comfort issues. And with comfort issues, that also brings up increased energy consumption, which is kind of what the IECC is all about, is lowering energy consumption at all possibilities. If there's a comfort issue, the homeowner is going to first start off by changing the thermostat to try to get themselves to a comfortable position or a comfortable temperature. That's going to increase energy consumption right off the gate. And then if it cannot get to that point of being satisfied, and or there's now humidity issues, not just temperature, due to ductwork installation being poor, now it's going to be a completely different phone call and another contractor and or the builder and or the city to try to fix this and find a solution. Things like this picture I took on the left, it's a duct chase coming down through the second floor. It's going into the floor system between the conditioned floors, and it's pulled too tight and it's collapsed over. That should be ran better. I mean, I know material is money, so they can't really add hard 90s on everything. If this was my house, that's probably what I would do to make this not be a problem and not have a point of being crushed at that floor system. But as you can see, it's hard to see in a 2D picture. But there was a little bit more room there that they could have actually had that a little bit more sweeping coming down through that floor system. And of course, on the right, you just have strapping at one point, causing it just to kind of collapse over. They could have moved that strap a little bit further back, and it probably would have had more of a sweeping turn and not just a hard 90 into that. And of course, it doesn't just pertain to HVAC ductwork. It also pertains to exhaust systems. So kitchen exhaust, bath exhausts, mechanical ventilation, we'll see more of those in just a second as well. But any ductwork you see that looks like this is going to be a problem with airflow. So anything that's installed like this, there will suffer from airflow issues that the fan may or may not be able to overcome that. If it's an ECM motor that can ramp up or down and kind of fix its own problem, then that might suffice. But those two bath fans on the right hand side more than likely will not have that type of motor in it. Once they're tested, if they're tested for Energy Star and or in the 2021 code, it has to be tested for efficacy. That more than likely will fail. And then the kitchen exhaust on the left, I don't know what else to say other than the fact that that's probably there was a better way to do that. So I understand that they wanted to install it that way. It was probably the easiest way to do it with the hard pipe. I wouldn't want to see flex duct there, but hard pipe, they could have installed that, I guess, that port a little higher, and it wouldn't have been like that. Testing of kitchen exhaust does have an exemption where if it's less than, or if it's 6 inches and it has only one turn, 190 in it, then it technically doesn't have to be tested. Something like this, you'd have to test it, and it probably more than likely this is not going to pass. So on the center and the right, of course, I understand the way it works in construction. You have the electrician install the fan housing, and then the HVAC guy runs the ductwork. But this is set up for failure. This is not going to pass. They both look like 80 CFM fans, means they're big housings, they're big 80 CFM fans. They'd be lucky to get less than 30 CFM out of that. So the fan efficacy table in the 2021 actually shows you a tested result. In other words, if you bought an 80 CFM fan and you could do the efficacy and say, well, with the power being used to get 80, it passes that table. But when you do real world tests in the field and it only is producing 30 CFM, it now fails the efficacy requirement and must be addressed. So if it's Energy Star, if it's not the 50 or higher, it won't certify as Energy Star. It's going to have to be fixed. So installing them like this, in my opinion, there should have been and should be a solution found where either both contractors communicate together with the best run duct way possible so you get the most airflow out of it. I know a lot of people just consider these to be fart fans. They're not really needed for anything else, but it is for humidity as well. And if it can't pull that out, it can be a problem to the structure in the long run. So these things should be addressed, in my opinion. Same thing with this. I took this picture last summer. This is not allowed anymore. I don't know why the builder was still doing it this way. Of course, this was in a much drier climate, not in what we see on the east side of Texas. It was in West Texas where it was a lot drier climate. So probably not going to be a huge humidity issue, but you shouldn't terminate these into the attic. They should be out the soffit vent, through the roof, coming down through the sidewall. If it's a 2-story, anything like that. Looks like the builder paid for the expensive 80 CFM fans, and then they just terminated up into the attic. This is kind of, in my opinion, a waste of money to buy those fans that expensive. They should have just gone with a cheap 50 if they're just going to stub them up into the attic. But this is no longer allowed in mechanical code. And speaking of mechanical ventilation, the ductwork issues that we just talked about, everything that we just went through, and looking at crushed ductwork and looking at hard 90s and looking at collapsed ductwork, it still applies to everything that moves air, and that includes mechanical ventilation and exhaust systems. These are ones I took in the field. These are duct issues, in my opinion, from the fresh air, aka mechanical ventilation system. So it's killing that system. It's either putting a lot of pressure back on the air handler, which is the one on the left is just using a simple damper system that's run off the air handler. And then, of course, on the right-hand side, you're just looking at a standalone inline fan with hard 90s and collapsed over ductwork coming out of that box. Those have ECM motors in them. They will ramp up or down, but that means that thing will run at high speed all the time, trying to accommodate for the fact that it has pressure issues and it can't get air down the ductwork, so it will prematurely run out. Eventually, that motor will burn out. So, um, the fan efficacy for looking at air handlers now in the 2021 and going forward is 3.8 CFM per watt draw. It has to be calculated usually in the field. The third parties will do the testing. They'll know how much watts, or they'll test to see what wattage is being used. But 2018 was kind of an issue with getting a modeling to pass if you're using the air handler as its fan source. In 2021, the air handler was added to that fan efficacy table, and technically means you should not be seeing the air handler being used as a mechanical ventilation fan source in an area that's 2021 or 2024 or even moving beyond and forward. Those should not be happening anymore because you're using way too much electricity and power draw from the air handler just to move a little bit of air. So those inline boxes, we've gone through all of this before, but those things are super simple. They're not very expensive. They can run 24/7. They usually have humidistats and temperature sensors in them. They won't run when it's 19 degrees outside like it is today in some places. It won't run if the humidity is too high. There's just parameters that you can set up. It's the right way to do it, but when you set it up to fail because you've now installed it and not thought about where the ductwork needs to go or how it needs to be ran, you're killing it. And then when that thing runs out and dies, if the homeowner is not familiar with what that's for and why it's there, they probably will not replace it. Other issues with mechanical ventilation, in the 2018 or older codes, it was not required to be tested unless you were Energy Star. It just had to be present and installed. Well, these pictures are ones that I took in the field. They were present, they were installed, but when you open the box and you look at from inside the lid, you see that they never even set it up. It's wired. It can run. Some of them were actually running and it had a high pitched whining sound, or you could smell the fact that the motor had already burned out. None of the cardboard was removed. Did it pass code? Well, for 2018 and before, it was just installed and it doesn't have to be tested. So technically, yeah, but this is not how it should be done. And then the one in the kind of the center there, you're looking at just a duct system that was, in my opinion, poorly installed. It was crushed before installation. And by the time it was crushed, that damper won't even open. This is a simple butterfly. It should just spring load, open, and spring close. I actually ended up looking in the plenum and down that duct, and that's how I got this photo. But that was pinched in that crushed lining ductwork that thing's housed in, and it would not function properly at all. So that would have to be fixed before any air movement. And the reason why we figured that out was because it was failing mechanical ventilation testing. So once it failed the testing, and we had to figure out a solution and find out why. The one on the right hand side, I don't really have enough words for excuses for that. I mean, is it there? Yeah. Does it have ducts installed? Yeah. I guess they assume the insulation doesn't matter because they didn't really bother to strap that down. It's just, again, this is most of the time these ducts ran into the return plenum, not directly into the house. So you're feeding this back into the system, and having it set up that way, it's not an excuse as to why that needs to be installed like that. And then a couple of pictures I just took here, food for thought kind of a thing. Um, if you're an inspector, you may see a lot of these things. That picture on the left-hand side, we're missing the outer lining, which we talked about earlier, was important to have in there to keep from condensation happening. Just a word of explanation, this duct system was actually a temporary housing for a raccoon family, and they found their way out in a couple of different spots, so it was completely destroyed. These ducts had to be replaced anyways. If you look close enough, it's in a foamed attic. It doesn't really need to have insulation. But the point was, for this presentation, it worked well for me to look at it and go, well, a lot of times the liner would get torn off from that vapor barrier and not replaced, and that's going to be a point of condensation. That duct will eventually, not in a foamed attic, hopefully, but it happens more often than not. But in a regular vented attic, that thing will end up being saturated with water over time, and that insulation is going to just deteriorate. That one in the center, we see this way too often. This is a mechanical ventilation fresh air duct that's actually coming out of the attic and is being pushed out the sidewall on a single story house. And I guess it could also happen on a two-story. but they're told to just put the duct there and the framer will come back and frame it, but make it as small as possible. So even if the mechanical ventilation was installed perfectly and correctly all the way in the attic, when it got down to this chase, the airflow has been ruined because it's just collapsed over and forced down a little place where a chase is going to be built is going to be crushed. We've seen a lot of times that they would make this as tight as possible and they would crush it against the boot that's running through the outer air barrier, and it would just cause that airflow to stop. And then when we started testing these due to 2021, we realized the issue is right here at the inlet. So um, you've already lost the airflow before it even made it into the house. And then, of course, the picture on the right hand side, I mean, we were failing a duct test, so we went looking for why and just happened to start like kind of a little bit tugging on some of these ducts just to see are they connected. And then, of course, this came up, which means I'm sure this was just a slip up. They probably meant to do this a little bit later, but they didn't plan for all the collars apparently. The collar wasn't installed, and they never even fixed this ductwork to that. So the only reason we found it was because it was failing a duct test. Another reason why those are so important to actually be done. And then last picture for this, then we'll get to some real examples of airflow testing is I'm sure the electrician was here first, and then the duct guys got there and decided to build a duct board return, and instead of telling someone where the wires need to go or doing something with the wires, which he can't do because he's not an electrician, he just set this on top of it. And I'm assuming without any presence of mastic, they're going to come back and seal it. But this shouldn't be happening. We shouldn't have electricity running through that. I know some fire marshals out there know that the jacket on this electrical wiring is and can be a contamination and a point of poisoning. So if this thing ever overheated and started to burn, it will actually filter back into that system and dump it back into the house. This, I don't know that this got fixed or not, but we shouldn't be seeing those kind of things. We shouldn't have pipes, um, either black iron gas pipes or having PVC pipes or electrical wiring running through returns. But this is not planned properly, and it was just a field decision to just put that here and hope that nobody noticed. And then what's the cost of doing proper duct installation? I know money, time is money, but what's the difference in properly, installed versus poorly installed ductwork? I found this online. It was just an interesting illustration about indoor climate system grading, is what they called it. We as third-party engineer or third-party inspectors actually always graded the installation of insulation. Now it's a grading system for HVAC installation. This is specific to grading of how well the ducts are installed. If it's Energy Star, you got to look at all of it and you got to kind of grade it, whether you're doing a grading system from A, B, C, D, and F, or you're just saying this is either a 1, 2, or 3, it's good or it's not good, it meets the requirement or it doesn't. There's ways to look at that and say, well, you got to grade it, which means we got to figure out a way to fix it. But with this, they did A, B, C, D, and F. A, of course, being the best. But if you look at it from that standpoint, if they installed perfectly using a grade A system, the best, it will increase costs of installation for ductwork from 12 to 14%. I don't disagree with that. I do look at that and say, well, I understand that that's the point and that's what we're looking for, but maybe that's not always obtainable and not always achievable. Here they state that a grade of D just meets code, which is 3 to 5% increased costs. One can say about looking at this grading system that since D is actually being met for code, doesn't that mean that they're installing it per manufacturer's installation instructions because that's what's required by code? I'd have to argue no. After doing this for over 12 years, I probably beg to differ to say around here, you're lucky to see a grade of C installation, which is about a 6 to 8% cost increase. If it's Energy Star, you got to be pushing that B or A at all times at even both return and supply duct systems. So that's not to say there aren't great installers out there and they take pride in their work, but the majority of houses being built today, I'll hold true to my previous statement that that's probably not what you're seeing out in the field. So now real world examples. This is one that I went through with a city. We actually looked at it from a builder standpoint. The third party went out and retested it. These are some numbers that they came up with. If you see on the left hand side, this is the manual J requirement for the entire house. 1160 for a supply. And then of course it lists it all by room by room by room on what the CFM that is required. And if you look out on the right hand side, far right hand side on that chart, they break it down as well and looking at it from a heating and a cooling standpoint from CFM. But this was during the summer, so we had the air conditioner running and we did actual airflow testing, and this is what we came up with. Those pictures you saw with the floor trusses, that's the house. This is where those pictures came from. This is the testing of where that came from. Those ducts didn't have much of a chance to start with once they got pushed into the floor system. We had the builder have someone to come in and do the testing for airflow, and it was proven that we've sustained a 30% reduction in airflow. So instead of 1160, we're looking at 814. And as you see, everything in red is what's being lower than what's actually has been designed for. So owner's suite, instead of having 143, it's 114. And then of course the great room, the big room in there is supposed to be 202, it's 123. Depending on the orientation of the house, if this great room is on the west, that's probably going to be a big issue and comfort issue. If it's on the south or the north, it may also be an issue with wintertime as well. But if you look at it from the right-hand chart, that great room, they list it there, 70, 140, and then 202 for cooling, but it's 140 for heating. It's getting close to heating, but it's really low for cooling, and that's when these things were tested. So this house is going to have occupant comfort issues and complaints. Again, it's the HVAC installer's issue of running ductwork, but he didn't have much of a choice. The truss systems weren't big enough. The ducts were getting compromised. They were using, I'm sure, R8 ductwork, which means it had a bigger outer insulation, causing it even more tighter spaces to run through. And then what can that have problems with? So return air issues. If you know anything about HVAC, if you don't get a system enough airflow back to the unit itself, you will have problems. You will get coils freezing both inside and outside. There will be comfort issues. There will be increased humidity levels. There will be air imbalances throughout the house. And even air imbalances, eventually it's just not going to work. You won't get air through a frozen coil like you see on that top center picture. That's a completely frozen coil, probably due to airflow issues, not getting enough air back to it, and or it could be a refrigerant issue, low on refrigerant. These are just two pictures I pulled off the internet. I'm sure it could or could not be. The one on the right-hand side could be a condenser for a heat pump. This is just giving you a good illustration of what could happen if you don't have enough airflow back to the system for the return. So you can have those kind of problems. So with that, though, we actually did the return air testing as well. And as we said earlier for supply, we had a 30% reduction. But on the return, there was only one on the second floor and one in the owner's suite, and we got 512. The system needs 1,160. So that return air reduction is about 56%. Again, I'm not a licensed HVAC technician, but there will be a problem with this system, period. There will be comfort issues. There will probably be premature failure of the system due to the fact that it does not have enough airflow into those rooms, and there will be issues that are called out. How you fix this is anybody's guess. There's not really a fix for this. This is we'll do the best we can and get it as close as we can, but it's never going to be correct. But this just goes to show, after you see all those ducts, and we looked at all those pictures previously, this is a tested result of what you get from having them installed that way. So it does and has big implications for airflow on new construction when it's not properly installed. And then we had another one come up too as well. This was another one that's I think there's still investigations going on. But as you see on the left-hand side in his report, he listed here that, like I said earlier, you've got ducts at the end of the plenum, which it shouldn't be. You've got ducts that are too close to the end of the plenum, which it shouldn't be. But he did test of airflow of all the bedrooms in there. There are occupant comfort issue complaints. That's why He was called out. He was not the contractor that installed the system. This is a foamed house. I don't know if they were having high humidity issues, but my guess is they probably were, and that's probably part of the house just doesn't feel comfortable and it feels stuffy. It's because the humidity is too high. So if you look at everything in red, that's most of that is all below what it was designed to be. And of course, in Texas, our big thing is we've got 90 or 9 months out of the year, if not 10 months out of the year, we've got predominantly cooling. If you're short airflow on cooling, that's where the complaints are going to come. It just, like I said, it was a big report and they're still looking into it. The CF film for cooling was 1670. You were actually pulling only 1426 out of that. There will be balancing issues. So if it's a 3-bedroom and you've got teenagers and they go to close the door, their room may stay comfortable until the door is closed. Once the door is closed, it gets too hot, it gets too stuffy, it gets this, that, and the other, or it gets too warm or too cold because too much air is being dumped into it because of balance issues. If it's code, nobody really tests the balancing. If it's Energy Star, you have to test room to room pressure balances, and that usually can be a tell sign that you've got something wrong with either ductwork, or you've got plenum issues, or you've got airflow issues to the system. That's also now why they're doing grading of the HVAC, is testing airflow, making sure that the air that's being produced is getting to where it's supposed to go and not causing pressure imbalances and temperature issues. So big takeaways from this, remember the 4 S's. So smooth, sealed, straight, separated, and not just separated from themselves. It's also not in contact with framing material, insulation, roof decking, service decking. I know it cannot be avoided at all costs, but do the best that you can to make sure that those things aren't just laying against stuff where they shouldn't be, just using it as a support instead of putting a proper strap that actually lifts it off, even an inch off the deck. If you know anything about radiant barrier and its power is its low emissivity. It reabsorbs heat, it doesn't re-radiate heat until it becomes in contact with something. Laying that against a roof deck, especially a radiant barrier decking, you're going to have a ton of heat being poured into those ducts and or leaving those ducts in the winter. You have to start somewhere. So just knowing, and that's why I had a lot of pictures today to talk about, was just knowing when something doesn't look right and that it's going to be, it could have been done better. Start making notes about what's happening in your area. You'll start learning real quick which installer or which ones. I know they have a lot of turnover with manpower. You'd get a crew in there that learns and gets good practices, and then a new crew that gets started and they need to learn those practices. But it's best to come up and say, this needs to be addressed, this needs to be fixed. Because though we didn't go through a lot of duct testing, manual J, manual S reports, or manual D, or HVAC grading, it all starts, in my opinion, it starts with proper duct installation to try to not harm what someone did to design the system properly, buy the efficiency equipment, and then you have poorly installed ductworks. Basically, it's just ruined everything that somebody just tried to do and what you're trying to accomplish. So nothing's going to be perfect, but it can be done better. Now you've seen pictures of that, you can kind of look at it and say, oh, I know this could be better. It could be strapped differently. There could have added another strap and have a wider swinging 90 instead of collapsing it over. Just know that when you see those things out there in the field, they are a problem and they will be a problem. So speaking of manual J and S, join us at our next webinar, especially if you're new to plan reviewing or you need a refresher. We're rerunning our presentations from Alex Meany from Mean HVAC, where we go through the manual reports to verify and look at it to see what's correct when you're looking at that. If you're not registered for our upcoming webinars, head over to our newsletter or head over our website. You can actually sign up for our energy newsletter. If someone gave you this link and you join, but you're not joined to our newsletter, that's how you'll get the webinar announcements and you'll get the registration links in that as well. And this is my contact information. If you want to share this with anybody, I'm happy to help as much as I can. I sit and answer phone calls pretty much all day long and emails with just issues that I can help with. Be sure and share my contact as much as you'd like to. And if you'd like to connect with us, here's one of our main numbers. We're also on X as well and LinkedIn. And now we're on Blue Sky. I believe we need to add that to here as well. But Thanks everyone for joining us today. I appreciate you guys being here. Hopefully you've learned a little bit from that. We'll continue our series of HVAC stuff and go down the line of looking at proper field inspection. I know by the registration we had for this webinar, that told me that this is the kind of stuff that you guys are looking for, is proper field pictures to know when it's correct and know when it's wrong. So I appreciate you guys being here, and thank you very much. I'll stay on for just a little bit. If anybody has anything in the chat, we can go through. Thanks again for being with us.